In traditional manufacturing, it takes months, if not years, to figure out the designs that you want to create, how you're going to produce them at scale, and it's very slow and expensive.
There's a variety of reasons why many industries have tried to get into 3D metal printing. Design freedom, production on demand. What Freeform does, it makes adopting that technology easy for everyone from the early phases of development all the way to full-scale production. In the existing environment, one has to make very large investments, buy expensive machines, organize their workforce around using those machines. It's a very complex technology, and the barrier of entry and the cost of entry for most industries is very, very high. So what Freeform essentially is trying to do is transform that space, bring the promise of 3D metal printing into reality, and effectively making it truly competitive with all other manufacturing approaches.
With Freeform, we're really taking this technology and opening up to wider markets, to really anyone that's using metal manufacturing.
As a business model, we provide manufacturing as a service. What Freeform provides is quality 3D metal printing at scale.
Anyone that's looking to make tens of parts, hundreds of parts, up to hundreds of thousands of parts can do that with Freeform. There are a number of other processes out there that tout high throughput, but you really sacrifice a lot of quality, control, and precision. Laser-based powder bed fusion is the only additive manufacturing process that really enables you to get extremely high precision and high quality and high throughput.
The multitude of lasers we have are able to align in real time. So our lasers are able to see the entire build area at all times. And so all lasers can work in parallel or together seamlessly. There's no issues of alignment or seams or any kind of defects that you typically see in a conventional system.
We are moving build modules through our light engine repeatedly, layer by layer, with multiple build modules. And then when that build is complete, the build module is able to move off to an unpacking station, get depowdered, and parts cut off the plate, fresh plate inserted, and back into the system, all automatically.
We've talked to a lot of customers that the only reason they're not using printing today is because there's nowhere they can get these parts at scale. So one of the foundational things that we did early on was architected a system that does not need humans in the loop, and what we had to do was actually close the loop on the process itself, add intelligence to the machine to transition from this human operator model turning knobs to an intelligent platform that doesn't need a human being to be doing things to get good parts off these systems.
It makes adopting that technology easy for everyone from the early phases of development all the way to full-scale production.
You don't have to have 50 acres of warehouses with spare parts anymore. You can just print on demand. And the thing that's limited 3D printing in terms of adoption has been that commercial technology today is not scalable. The only reason it's not being used as a conventional manufacturing replacement today is because cost isn't there, the consistent quality isn't there, and it's just not scalable in its current form. And so that's what we're doing here, is setting out to build these autonomous metal printing factories that bring the economics in line and the scale in line with mass production needs.